Hello students, Mr. Guest speaking. I appreciate you all checking out another set of my notes. Again, you're watching Mr. Guest Notes, and these notes on plate tectonics. Students, please, if you will, watch the entire video. Watch the presentation in its entirety before you start taking notes. Make sure that you're actually getting something out of this. I know you might have missed the assignment and you're just trying to catch up. But go ahead and watch it through. Listen to the lecture, listen to my key points, and then jot down those notes. Let's move. As you know, we always start off with a question. Try to get you thinking. Answer this for me. How does a volcanic eruption relate to plate tectonics? All right, how does a volcanic eruption relate to plate tectonics? Your answer is volcanic eruptions occur when there is an opening, any size opening, in the surface of one of Earth's tectonic plates. We know that all the plates fit together. Every now and then there's a break or a crevice that this lava, this magma can seep up through. When that happens, you have a volcano. Now sometimes volcanoes erupt, boom, huge explosions. But sometimes, like in shield volcanoes, the lava just flows from beneath the surface. They're still called a volcano. Moving on. Earth's crust and the upper part of the mantle is called the lithosphere. The lithosphere is Earth's crust and a solid part of the mantle. Again, that's this definition. Earth's crust and a solid part of the mantle. Talking more about tectonic plates, like a cracked eggshell, the lithosphere is not a continuous layer. It is broken into pieces called tectonic plates. And here's your second definition, plate tectonics. The theory that the Earth's lithosphere is broken into about 20 moving plates. I'll say that again. Plate tectonics is a theory. It's not a law. It's just a lot of scientists believe this to be true. We have a lot of evidence, but we can't prove it. Plate tectonics is the theory that the Earth's lithosphere is broken into about 20 moving plates. Key word is they're moving. They're continually moving all the time. The theory, again, it's a theory. The theory of plate tectonics explains features such as mountains and volcanoes. Now, what powers this magma beneath the surface, beneath the plates, is convection. Convection currents within the mantle causes Earth's plates to move. We've talked about convection before when we talked about our atmosphere and air, the fact that warm air rises and cool air sinks. The same is true with liquid. Now, we know that magma and lava is liquid. It's very, very thick, but it's liquid nonetheless. So the warm magma rises to the top and it pushes or forces the heavier, cooler magma to sink. And of course, it gets its heat from the core. The Earth's core is very hot, almost as hot as the sun, some scientists believe. So it warms up this magma, and that warm magma rises to the top because of convection, forcing the cool magma back down towards the core. Talk about Alfred Wegener. Continental drift, seafloor spreading, plate tectonics, Pangea. He came up with all of this. All right, he's the genius when it comes to plate tectonics. He started it all. Alfred Wegener, a German scientist who introduced the idea that the continents drift slowly over Earth's surface. Wasn't well accepted at the time. Wegener proposed that 225 million years ago, the continents were joined in one large supercontinent he called Pangea. Now, Wegener also introduced the idea of continental drift. Another definition. Continental drift, the theory, again, it's another theory. We can't prove it. The theory stating that continents are continually or constantly moving. If we look at this picture, let's blow it up real quick. And we come to it, boom, expand. As you can see at the very top part, right up here. Very top part, 200 million years ago, Pangea was just starting to break apart. All right, now if you look at it today, this is about almost exactly how our globe looks today. Now, if you estimate 50 million years from now, you can see that it's going to change in just 50 million years. Now, I say that like just 50 million years is next week. And when we're talking about the age of our planet, 50 million years is pretty soon. So you can see that it's going to change a little bit. Look up here where you got Cuba and the Bahamas and the Caribbean islands. Now they seem to disappear or they merge with South America. Just the same. Right here on the continent of Africa, you can see this peninsula or it's starting to actually break apart. All right, so small differences. You see the Red Sea. If you're familiar with your geography, the Red Sea is actually expanding right here. It's bigger. It's bigger. All theoretical, but this is what it's projected to look like 50 million years from now. All right. In 1931, Alfred Wegener froze to death studying glacial movement and polar climates in Greenland. He had moved on. He had moved on. A lot of people didn't accept his idea of Pangea. They didn't accept his idea of continental drift. How are these huge continents moving? Please give me more than just some fossil records. Remember, this is a long time ago, 1931. All right, so he moved on and he was pretty much studying climate and the climate in Greenland. While he was doing that, he died in a massive blizzard. Massive blizzard. So he never lived long enough to actually see people start to accept his theories. More about Wegener. Unfortunately, scientists dismissed his theories because he didn't have any proof. However, because of advances in technology today, Pangea and continental drift are now well accepted theories. But just the same, there still is no proof. We still can't prove it. Hit you with some more vocabulary that pertains to plate tectonics. Now, a fault is a break in Earth's crust at the boundaries where plates slide past each other. Again, a break in Earth's crust at the boundaries where plates slide past each other. And we know that plates have three main different types of movements. You got divergent when they actually come apart, and that's actually showed right here. You have convergent when they actually come together. As you can see the arrows pointing, these two plates are actually moving towards each other. And you have transform when they're sliding past each other. This part right here, this type of boundary, transform, causes the most earthquakes. Got it? More vocabulary. Now, the New Madrid or New Madrid fault is an active fault which is located in northeast Arkansas, where we live. And as you can see, this is a transform boundary right up in Jonesboro. This picture was taken, and you can see, yes, Arkansas, we do experience earthquakes. We do. We have a major fault line called the New Madrid, or some people pronounce it New Madrid fault in northeast Arkansas. And young people, that's the end. Shout out to Alfred Wegener. I appreciate all the information and the theories you've given us so we can study and learn. I'm sorry you didn't live long enough to actually see yourself become famous, really. And students, that's it. Make sure that you watch it first. Hope you watched it first. Now you can go back and take notes. I'll see y'all later.